So when I was applying the elements, so firstly, these characters inside these boxes, they represent the symmetry or antisymmetry with respect to that particular element. For, for example, if you'll see underneath identity, everything is positive. That means it is symmetric. Okay. Other than that, with respect to the C to Z, it could be like symmetric. That means it is not changing anything. And if it is antisymmetric, that means something has been changed. So one sign or minus one signs can correspond to that one. Similarly for all the sigmas also. So when we have filled first line as 1, 1, 1, 1, that is called completely symmetric. Now, what about the other three irreducible representations? So I have given this name as D, E, and F. So I'm saying when I'm multiplying first row with the second row, the total value should be 0. How is that possible? So this is 1. This already we have given 1. 1 into 1. Here we have to multiply the coefficient also. But since this coefficient is 1, so 1 into 1 into 1 doesn't matter. So I'm just writing the characters only. Next one is 1 into D. Other one is 1 into E plus 1 into F. That should be equal to 0. That is the postulate. Now you tell me if I have 1 plus D plus E plus F equals to 0. And when I'm saying the characters corresponding to the different elements, whether it is symmetric, that will take +1 value, whether it is antisymmetric, it will take -1 value. These are the only two possibilities over here, right? So if I have taken first case that D is +1, I'm going symmetrically from high symmetry to going to the lower symmetry. So when I have given D as a +1, that it is symmetric with respect to the C2. So what do you think these E and F would be if we need to have the 0 value? They have to have the -1 value, then only it would be 0, right? Is there any other possibility that we can have besides this -1 over here? Do you think of any other number to put here to make it 0?
Okay, ma'am. If I will put a 2 plus 2 minus 2 minus 2, that also equal to 0. But
right, that is right. But we need to see if I have put this as 2 and this as 2, you have to square them and it should be equal to your order of the group. Our order of the group is 4. We cannot have 2 in that case. We already see right here. So when we were doing here, so if I will take in this particular case, I have to like what values I can put. So if I'm taking 2, that square root of 2 would be 4. So other values have to be 0. Right? So the other values would be 0. So that is not possible in cases that I mentioned. Therefore, 1 is the only value or the -1 is the only value that we can put. Underneath the identity, since it is a dimension, we cannot have negative or 0 value. So all the values are positive and 1. Here we can have plus or -1 corresponding to when we are multiplying the two irreducible representation, it would give us 0. That's why when you are saying it can be 2 plus 2, but if you square that 2 square plus 2 square, that would become as 8. Right? So if you want me to put here as 2, firstly the 2 is not possible here. If this is 2, then others have to be 0. Because the squares have to be, when they are added, that should be give you order value of 4. So if you're already given the highest value 2, its square is 4. So you cannot have any other value in addition. So you are understanding my point. Many possible.
okay, ma'am, I understood.
But we
Okay,
need
okay.
to
If
order of the group.
if we put a 2 means that will be create problem.
Yeah. So this is the way we get the C2V point group. Now, when we have put that characters over there, how do we give the symbols to these irreducible representations, which are called the Mulliken symbol? So rule says, firstly, we take that. Okay. So rule actually says to find out the Mulliken symbols. Rule says if underneath E, you have the dimension of 1, then it will give you symbol of A or B. If it is 2, the symbol is E. If it is 3, the symbol is T. Normally, in the most of the character tables, we have seen up to T only, not more than that. There could be many, but we are restricting up to 3. So these are the symbols. These are the Mulliken symbols that we give underneath. These are the characters under, this is the character under identity element, right? Now, for the principal axis, this n can be anything. This is the proper axis of highest rotation. So if this value is +1, okay, if this is +1, so it will give you 1, A. If it is -1, it will give you B. Out of the A or B, if it is +1, if the character is +1, it will give you only +1 or -1 value. If it is symmetric, then it is A. If it is antisymmetric, it is B, the symbols. Other than there, if there is any C2 axis which is perpendicular to Cn, then if it is +1, then it is giving you 1 symbol. If it is -1, it will give you 2 symbol as a subscript. If C2 is not present and sigma is present, sigma V is present, so then again +1 will give you 1, -1 will give you 2 as subscript. If sigma H is present, which is symmetric, then it will give you dash sign as a superscript. It is -1, it will give you double dash sign, that is your superscript. If I is present, if it is +1, this will give you G. If it is -1, this will give you U. So this way we get to know to form our Mulliken symbols. So this is there. Now we will find out the Mulliken symbols for these one. Now firstly check underneath identity, the value is 1. So we said if identity dimension is 1, then the symbol can be A or B. Clear?
Okay, clear, ma'am.
Okay. So right now we don't know whether it is A or B. So for sure it is not E, for sure it is not T because the dimension is 1. For 1 it is A or B. Now look for C2. This is the maximum principal axis we have. So value of C2 is 1. For 1 we said what would be the symbol? A. If it has been -1, then symbol would be B, right? Now you tell me if I have identity A or B, now underneath C to Z, it is 1. What would be the symbol, A or B?
Yeah, ma'am.
What about this one? Because these are all also 1, 1, so either A or B. So this is 1. What would be the symbol? This is also 1, so there is no question of having A or B, so we know. But underneath of C to Z, it is again symmetric. So what would be the symbol?
Yeah, ma'am.
What about this one? It is antisymmetric now.
B, ma'am.
And last one,
Also B.
you've understood this point? Now we need to give 1, 2 if anything else is present. Now there are sigmas XZ and these are perpendicular to C2Z. Okay, so when we have just a second. So these are our so now then we were saying that if C2s are not there, we need to find out whether sigma V's are there, and these are sigma V's. And if the value of sigma V, the character, it is +1, it will give you a subscript of 1. If it is -1, this will give you +2. Okay. So sigma XZ, we are taking any of these two. Sigma XZ, that is 1, right? This is symmetric. Now the symbol will become A1. It is antisymmetric. -1, it will become A2. This is symmetric, this will become B1. And this is antisymmetric, this will become B2. So these are the Mulliken symbols for, or you can say, these are the irreducible representations for C2V point group. You're understanding how do we get to know from the character table what will be the irreducible representations of a particular point group.
Okay, ma'am, I understood.
So I know this is a lot to grasp, but this is an additional topic which I wanted to explain because in group theory, the most important topic is the character table. From the character table, what are the irreducible representations? And this will help you in many, many aspects, not just the CD spectroscopy or mass spec. Maybe if you're just looking around the coordination chemistry, you're learning about the splitting patterns, how that terminology comes into picture, how the symmetry is related, all these values will be helpful. So this is just a basic that I wanted to share with you. So you can go back and then try out some other examples, try out with the C3V point group and say, check whether the character table you are able to assign the irreducible representations or not. So yeah, this is the thing that I wanted to explain in the extra live session. So besides this, is there any doubt that you have what I have taught today? Or is there any other doubt you are having? Because today would be the last session.
Just a small confusion in circular dichrotion
Which question?
CD. That is a positive, negative CD curve.
I didn't understand. I didn't understand your
Positive,
question. Can you please elaborate it?
not need elaborate, ma'am. That is in a simple. What are the main definition and the principles involved in the CD?
You're talking about circular dichroism.
Yes, ma'am.
Okay, that plus and minus sign that we were talking about, alpha and beta sheet and random coil.
Yes, ma'am. Yes, ma'am.
So we have actually taken up that, right? How? Say, this was our side. This is a positive sign. This is a negative sign. And here we were saying that in alpha helix, it is having how many bands? 3 bands. Second is beta sheet, which is having 2 bands. And random coil, that is having 2 bands, right? So alpha starts from the positive and it is having 2 bands in the negative region. Then we have beta sheet, which also starts from the positive but has only 1 band in the starts from the positive and have 1 band in the negative region. And random coil is the one which goes from negative to the positive. So this one is called random coil. This purple one is your alpha helix. And this orange one is your beta sheet. So what is the confusion that you're having?
Okay, ma'am, I understood. The alpha helix and beta sheet starts from positive to negative side.
Yeah.
The
So,
random coil starts from negative to positive side.
so first thing is very clear because 2 of them, they start with the positive side. So you need to remember that alpha helix is having 3 bands. So whenever there is 3 bands, that is alpha helix. So the question is gone. If there are 2 bands and it is starting from the positive side, that is beta with 2 bands. And if it is starting from the negative side, that is your random coil. So you can remember.
Okay, ma'am.
Okay. Any other doubt?
No doubt, ma'am.
Okay, so all the very best for the exam. When is your exam for this course?
28, ma'am. Coming 28.
Okay, all the very best. Do well, and I hope I have tried to help you out with some of the doubts that has covered all the syllabus. So yeah, do well and try to read all the concepts, understand it, and try to practice a lot. Go and search online and find out all the possible questions regarding circular dichroism and MOSFET spectroscopy. Once you have understood the concept, it would be very straightforward to answer any question. But maybe the language would be different, but the concept would be the same that you have already understood. So yeah, do well for that exam. All the very best.
Thank you, ma'am.
And if you still feel that you have any doubts, since we won't be having any other live sessions from now onwards. So you might be having my email ID. I've already given my email address in this all the videos. So you can just mail to me regarding your questions. I will just write here my email address.
Okay, ma'am. I will search in this website.
No, I will directly give here. So this is my email address. You can directly mail to me if you have any doubt and question. So if I'll be knowing the answer, I'll try my best to get you the answer as soon as possible so that you will not feel any problem in preparing for your exam. Because from 15 to 28, you still have a lot of time. You can search a lot of books, go for the authentic books and find out the different problems and try to solve them out and cover the whole syllabus. And in between, if you revise these lectures because they are already been uploaded on YouTube, so you can go back and revise them also. That would be very beneficial while preparing. And if you find any problem, you can just let me know via mail.
Okay. Okay, ma'am. Thank you.
Okay then. All the very best. Then I'll end this meeting.